Hello, y'all. Time to look at combinations of n objects taken r at a time. This is going to differ from what we did last time in the sense that last time we said if you had the letters A, B, C, how many ways could you arrange them? You could have A, B, C, A, C, B, B, C, A, and you could figure out how many ways you could arrange those letters. Today we're saying just what's a group of three letters. It would be A, B, C. So it wouldn't matter if it was A, B, C, or C, B, A, just which three letters do we have. So a great big distinction between yesterday and today is combinations are a selection, okay, of an object where order is not important. Now, last time we looked at permutations, order was important. That would be like words or codes, passwords. Order matters. Combinations is just how many ways can I get, if I pick a group of 3 kids out of my classroom, how many ways can I do that? It doesn't matter if I pick the first 3 or second first and then first. So let's look at these. Right? This is how you would do this by hand. You would use factorials. We don't really do it that way anymore. We use our calculator. If you've got the older calculator, it looks like this. If you've got the new one with the LED screens, you just hit math, right? And go over to PRB, or PROB actually, prob for probability, and you're going to pick number 3 NCR. All right, a standard deck of 52 playing cards has 4 suits with 13 different cards in each suit. The suits would be diamonds, so you could have diamonds, hearts, clubs, and spades. That's what it's talking about when it talks about those 2 suits. And as you look at this formula, N is how many are available. Could be cards in a deck, it could be kids in a classroom, but how many are available? And R is what you want. Like, let's say I want to make a committee with 3 kids, then R would be 3. So let's look at these. They're really pretty easy. If the order in which cards are dealt is not important, how many different 5-card hands are possible? Well, I have 52 cards to choose from, and I want 5. So now it's a matter of plugging that into your calculator. 2,598,960. Please pause and punch that in, make sure you can. Okay, if you're back. Remember, this is what you want, right? 5 cards, and this is what's available. Now, this number of what's available isn't always as easy as 52. If I said I only wanted red cards or black cards, then I would only have 26 available. So you've got to watch that number and think for a minute about what that number's asking. Okay, in how many 5-card hands are all 5 cards the same color? Okay, so here I've got 2 things going on. First of all, I'm going to pick, I have 26 cards now because there's 26 red, 26 black in a standard deck of cards. So I'm going to say I have 26 cards to pick from, and I'm going to have 5 of them, and I have to multiply it by the combination of a red or a black. So 2, I want 1 color, and there are 2 colors available. So look at this one, it's a little bit different. This one, we didn't put any restrictions, it's straightforward. There's 52 cards and I want 5. Now I have to start thinking about the same color, and these will come with practice. As you see me do some, you'll be like, okay, I need to include this or that. So 26 of 1 color, and I want 5 times the combination of 2 colors taken one at a time. And if you type that in, you're going to get 131,560. Okay, example 2, add or multiply. William Shakespeare wrote 38 plays that can be divided into 3 genres, 18 comedies, 10 histories, and 10 tragedies. So how many sets of exactly 2 comedies and 1 tragedy can you read? Multiply, right? Because it's and you can kind of think about this as an and. I want all 1 color and I have to pick that color. So this is going to be, let's see, 2 comedies. So there's 18 comedies and I want 2 times 10 histories and I want, or no, 10 tragedies. I want tragedies. And there is 1. And so pause it for a second, type that in, then bring me back. There you go. How many different sets, at most 3 plays, can you read? Okay. At most 3, what does that mean? Means you can have 3 plays or 2 plays or 1 play or no plays, right? So I could have this or this or this or this, and y'all know that the word or means to add. So 3 plays. Well, there's 38 plays altogether, and I'm going to pick 3. I could have 3. What if I only had 2 plays? Well, there's 38 plays available, and I'm going to choose 2. Or what if I choose to read 1 play? Or I choose no plays. So there you can just punch that into your calculator, and I think you get 8436 plus 703 plus 38 plus 1. So that is 9,178. So kind of look back over this and use this as a guide when you work. And I am going to do some problems with you. But what we're going to look at on the next page is comparing the 3 things that we've just learned how to do. Day 1, we did a tree diagram. I hope I was on there. Was I on there so you could see what I was writing down? I just realized, I don't know if I moved the paper. So here's this paper if you need to pause it and look at that. Okay, so we did 3 things on 3 days. We did a tree diagram, a permutation, and a combination. I'm going to combine all those for you to show you that you could technically use any of those methods and still get the same answer each time. So let's look. Let's look at a tree diagram first. And remember, a tree diagram is when you have small samples. If you have a large sample, that's just simply too much work to do, right? So tree diagram. Small samples and usually multiplication, right? So given the top 2 cards from a deck of well-shuffled playing cards, find the probability of 2 aces. Okay, that should say TWO. That's a typo on my part. So find the probability of 2 aces. So here I am right there, and I'm going to choose 2 cards, right? And then I'm going to choose again. So we're going to say that I get an ace or not ace. Because remember, I'm picking 2 cards, right? And then I draw cards again, and I could get an ace or no ace. Could get an ace. Maybe I'll get no ace. So let's see, what's the probability that I'm going to get an ace the first time? Well, there's 4 of them. So 4 out of 52. What's the probability I won't get an ace? 48 out of 52. Now I picked my card, so in this line, 1 ace is gone. So what's the probability I get an ace this time? 3 out of 51. The probability I don't get an ace is still 48, right? But out of 51, because 1 card is gone. Now, if I go this route, I did not get an ace. So what's the probability I get an ace this time? Well, there's still 4 aces in that deck. but there's only 51 cards. Down here, I took 1 card, so now I have 47. Okay, so here's our tree diagram, and you know how to do a tree diagram. So the probability of 2 aces here is going to be 4 out of 52 times 3 out of 51. And that is what? Work it out on your calculator. I got 0.0045. Now I could work all the rest of these out, but we're interested in the probability of 2 aces. So the probability of 2 aces, if I pick 2 cards, is 0.0045. Okay? Now let's look at a permutation where arrangements matter. Right? So what do I want? It's, remember, for probability, it's always what you want over the whole, right? So what do I want? I want 4 aces. There's 4 aces, and I want 2 of them. That's what I want. 4 aces. I want 2 aces. And I'm going to choose those out of the whole deck. There are 52 cards in a deck, and I'm going to choose 2. So pause this, take a second, and plug that into your calculator, right? Remember, alpha y equals 1 will give you the division symbol, and you get 0.0045. Now we could do a combination. Individual of a group or order does not matter. And I really don't care if I get an ace of hearts first and then an ace of clubs. So again, it's what I want out of the whole deck, right? Probability of anything is always what you want out of the whole thing. So I want 4, I have 4 cards and I want 2 aces, and there's a possibility from 52 cards, and I'm going to pick 2 of them. So if you type that in, what do you get? Pause and look at it. So I just wanted you to see this, to notice that combinations, permutations, and tree diagrams all work when we are looking at probability. So that's it for now. You can close this video. I am going to do some more notes, kind of homework with you, and practice some of these. See you in a bit. Bye.